Okay. So, how do I use this? But because there are people who will be undergoing quarantine, self-isolation, I don't even know if there will try. We are going to, so every lesson I try to record, okay, or do a live session. So if you happen to be stuck at home, this is what I will do from now on. Okay, I will share the link with you. You should be joining. This is a Zoom live session at the moment, but I'm also recording it. But I don't know how clear it will be later on when we play back. Then I can check if it is clear enough. You can see my, sorry, you can hear my voice, but you definitely can see my slides. Okay. If the audio is not clear, that means I will bring the my laptop closer to me. That just means that you won't be able to see the whole slide. Okay. Right. So for today's lesson, we are going to just finish off this paper, practical number 9, which is the last one that we did, I think, early February, if I'm not mistaken. Okay, and then anything after we're done with this paper, after we're done discussing, I will just go through the general things to remember for your practical tomorrow. Okay. Right, so as you said, we have done question 1. Now, question 1 is not a typical, the calculation is not as typical mole calculation. Okay? Whenever you see the keyword remaining, okay, you have to understand and read the question. Usually there are 2 parts, 2 reactions. Okay, just like this reaction. The first reaction is sodium carbonate reacting with hydrochloric acid in excess. That's your first reaction. Okay, so I showed this to you last time. Sodium carbonate reacts with HCl, and then the second reaction, any remaining or unreacted HCl will then be titrated with sodium hydroxide. Okay, so when you see the keyword remaining, is reacted further or reacted with other reagent, that means you must remember these 3 things: initial, reacted, and remaining. Okay, so that's why I have one student asking me, Miss, how do we know that someone is admit me now? How do we know that when do we find the number of moles of initial, number of moles reacted, number of moles remaining? So you have to read the question. Okay? Hi Nina, let's hear out.
Hi, Miss.
Someone is not gonna reply back. Okay.
Apa?
Okay. Right, so I will not go through this whole calculation because this is something that we have already. But here's my point: NHCl reacted equals to initial minus remaining. Okay, because I have one student asking me, Miss, how do we know when to use initial, remaining, and excess? So usually it is when they mention the word any remaining reagent or any unreacted reagent is then reacted further with a different reagent. So that's when you know this kind of calculation will come in. Now, as I said, this is not the typical mole calculation. It's not to say that you won't be able to do it. You can do it, but a little bit lengthy. Okay. We have also talked about this part D. Have we discussed part D? Yes. Okay. Right, now we move on to question 2. I also don't remember what we did in question 2. So you heated a solid Okay, you will determine its relative formula mass. So if you, sometimes it helps to just, read quickly the little bit of introduction to your practical. Because I know all of you will just jump straight to the method because you want to start with the practical as fast as you can. Okay, so check your tables and then check your units as well. Always, in your case, in the exam, always circle or underline where it says weigh, report, calculate. These are the things that you have to include in the table. Okay, so can you see that? Weigh the crucible with its lid, reweigh, that means you need another mass. Reweigh the crucible again, calculate the mass of FP4, mass of residue, and mass of water loss. Okay, so in our table, we've got mass of empty crucible with lid. So this is when before you add the solid. Okay, mass of crucible plus FP4 plus lid before heating. Okay, and then you have mass of crucible plus residue plus lid after heating. Now residue is actually your FP4 after the reaction has been completed. Okay, well we think that it's completed. Mass of FP4 you have to find mass of residue again. Residue is the solid that you are left with after heating. Okay, mass of water loss. Now I still have students struggling with how to find the mass of FP4, how to find the mass of residue, how to find the mass of water loss. Okay, if you want to find the mass of FP4, which is the solid that we started with, we take 2 minus 1. Are you all okay with that? Okay, so it's 2 minus 1. Because 1 is just the mass of the crucible, and 2 is the mass of crucible plus FP4. So if you minus these numbers, then you should get just the mass of the solid. Mass of residue is the mass of the solid that are left with after heating. Okay, so this is also a common mistake made by students. To find the mass of residue, you see here, this is the mass of your crucible plus residue minus the mass of the crucible alone. Okay, so that's 5 minus 1. If you take, if you take 3 minus 1, you should be able to work out the mass of solid after heating, which is your residue. Mass of water loss. Mass of water loss, if you look at meta, they don't tell you the equation. But what happens is that when you heat this sulfate, okay, you will form a residue plus H2O, which will escape or evaporate as gas. Okay, so if H2O evaporates as gas, you would expect, I think FP4, and then whatever solid after that, you would expect the mass of FP4 to be a little bit higher than the mass of residue. Basically, there will be a decrease in mass. The reason for the decrease in mass is because the H2O has escaped as gas. Okay? Is that okay? So whenever you have release gas from heating of a solid, you would expect the mass of the solid to decrease. Okay? So this will be evaporate as gas. So you would expect your mass of solid, mass of residue to decrease. Okay, so how do we find that mass of water loss? Well, you take the mass of your residue, sorry, you take the mass of your aquifer, which would be higher, minus the mass of residue, which should indicate the difference in mass between these two would be the gas that has evaporated or the gas that has been lost. Okay? So mass of water loss is 4 minus 5. Are you all okay so far? Does that make sense? How you find or how you calculate the mass of aquifer, residue, and water loss? Okay? If you don't get it, please let me know. Okay. Okay, then the question wants you to calculate the number of moles of water loss when your sample was heated. Okay, so we want to find number of moles of water that is lost. So you already know the mass. Yeah, the mass from here you know, right? Okay. So to find the number of moles, convert to the number of moles, you take the mass divide by the MR of water. Yes, that's how you find number of moles. I don't have my mass as I didn't do my experiment very well. Where do you have a value for the mass of water loss? Did you manage to get anything? Huh? So what's your mass loss? One point? Is that the number of moles or mass? I think it should be something smaller for that. What's your mass loss? I don't know how you do. One. 1 gram. Okay, so that should be correct at 1.1 grams. Okay, so you just take 1.1 divide by 18. So you should get whatever your mass loss is. Okay, so you follow your own results from your experiment. That's number 4. Write the equation for the reaction that occurs when this metal sulfate is heated. Okay, so that is the equation. When you heat the M sulfate with 7H2O, what you are doing is actually the residue is actually MSO4, where M is the group 2. Okay, so it's metal sulfate solid plus 7H2O. So that means, so this is the reason why there's a decrease in mass. Okay, after you work out the number of moles of water, and then you got a balance equation, making sure that the equation is balanced. You want to find the number of moles of metal sulfate. Okay, so from the first part, you already know the number of moles of your H2O. Okay, with mole ratio, the number of moles of metal sulfate and H2O is 1:7. So you can find the number of moles of metal sulfate if you know the number of moles of H2O. Then work out the number of moles of the sulfate. You got that already? Okay, let's move on to the next one. Okay. Then we want to find the MR. If you know the number of moles of MSO4.7H2O, you can then find the MR by using the mass of Fe4 over the number of moles of MSO4.7H2O. So basically, it's mass over mole. Now the mass, which one are we using? Is the mass of this formula, because you want to find the MR of that formula, right? Okay. So the mass, we have to use mass of Fe4. Right? The mass of Fe4 and the number of moles of MSO4.7H2O will be the same. Okay? Number of moles of MSO4.H2O is the same as the number of moles of MSO4. How do I know that? How do I know that they're the same? Because according to the equation, it's 1 to 1. Okay? So I don't just say, oh, the number of moles of my metal sulfate and metal sulfate is the same, because they are 1 to 1. My answer from part 2 here tells me the number of moles of metal sulfate. And because it is 1 to 1, I can say that the number of moles of my metal sulfate dot 7H2O is the same. Are you all following here? Okay. So if I know the number of moles and I know the mass of Fe4, to find the MR, I just rearrange. Okay. MR is equal to mass over N. So the explanation for this is 1 to 1. Okay, once you find the MR, you can now find the AR of M. Did anyone find the MR already? Did you answer? It should be around 300 number. 281.1. That is about. It should be around 200. Yeah, you'll get this. As long as it doesn't have to be 281, because you use different mass and then you carry out different practical. So your value would not be the same. You should not get exactly 281, but they should be close to that number, right? And to find the AR of M, you would, when you add the AR of M plus AR of sulfur plus 4 times the AR of oxygen plus 7 times the MR of H2O should be equal to 281. Okay? What's the answer? 98.9. Oh, sorry. That's like more than 16. 58.9. Okay. So whatever your answer is, okay, so for example, if I use this value, it's 8.9. And if you read the first part, M is a group 2 metal. So you should find a group 2 that has the closest AR to 58.9. Okay, so in my case, the closest one is calcium, 40.1. Okay, but I don't know if it's the same for everyone. So in this case, my metal is calcium. Okay, anyone else who did not get a whole number, like they got 0.00 something? No? So if your number, your AR is not a nice number, so that means there's either something wrong with your calculation or there's something wrong with your practical. Okay, maybe when you measure the mass, something happened, or when you were transferring or during cooling, you dropped some of the solid or something, many things can happen. Okay, so what sort of value are you getting for your AR? 59, okay, that sounds okay. 58, anyone else who gets a different element, a different metal? Everything? 17? 17. So in your case, if you get 17, your metal would be magnesium. Okay, so your answer will be magnesium. All right. Now in this case, because it's based on your measurement, so you will get different answer. They will still accept your answer. Okay, so just because your metal is different from your friend, it doesn't matter. All right, even for myself, I don't know which one is the correct metal. I haven't checked the piece. Okay, so as long as your number is a nice number, whether it's between magnesium and calcium, beryllium very rarely happens. Okay, very rarely. But if your number is close to beryllium, then you take beryllium. Right? Okay. Moving on to the explanation. In the method used above, the lid was placed on the crucible when the crucible was left to cool. Now, the most common reason that I see explain why the lid was placed on the crucible. Some of you said so that the water doesn't escape. Okay, that's the most common reason that students always put. Now, we actually want the water to escape. We want them to evaporate as gas. Okay? Otherwise, if we don't let the H2O escape, then it will affect the mass of our residue. Okay, remember, as I said just now, whatever mass we have lost as gas, that is the decrease in mass from the FB4 to the residue. For example, I started with 5 grams of FB4, for example. Okay? And then my residue is 4.5. So there's a decrease, right? So that 0.5 grams is associated with the gas that has been formed. And I need to let that gas escape. I do not want to take the mass of the gas. Because if I don't let this mass of the gas escape, my residue will still be 5 grams. Okay? And how can I do my calculation? I don't know how much gas has escaped. I don't know how much mass is of residue. Okay? So in this case, the reason why we put on the lid during cooling is not because we don't want the H2O to escape. Yes, we do want it to escape. But this time we do not want any additional water from the air vapor to get in contact with our residue. Okay, if we have external, say H2O vapor from the air, okay, not this one, not this one. This one already evaporated. Assume that already evaporated. And then additional H2O gas from the air gets in contact with the residue. So the mass of the residue will now go up, and it's not accurate anymore. Okay, so that's why after letting the H2O escape, and we want to pull the solid, we have to protect the residue so it doesn't get in contact with the water vapor around it. If it does make contact, the mass of the residue would be higher, or what we call overestimated. Okay, so that's the reason why during cooling we want to put on the lid. Okay. Suggest an explanation, the effect on the calculated value of the relative atomic mass of M if the lid has not been placed on the crucible during cooling. Okay. So here, if we don't use the lid, they say the mass of water lost will be less. Therefore, the number of moles of H2O will be smaller. Okay, right. So now they're asking what is the effect if we the lid has not been placed. So the number of moles of H2O, the mass of residue will be higher. Okay. So we cannot talk about the residue because in our calculation, we are only using the number of moles of H2O lost. Okay. So if we had lid, we start with not using the lid. Okay. Let me try using numbers. Okay. So with the lid on, with lid off, yeah, with lid off, the mass of aquaphor, for example, is 5 grams. Okay, and then we say that the mass of the residue would be 4.5, and then the mass of water that escaped is 0.5 grams. Okay, this is if you have the lid on. If we have the lid on, okay, lid on, okay, on 4.5 grams of the residue, and then 0.5 grams of water. Okay, with the lid off, we also say we start with the same mass, 5 grams. Okay, this time, our water has escaped. Okay, but now water is coming in contact with our residue. Okay, so for example, 4.5 plus say 0.2 grams of the water from the external. Okay, so how much left of water is lost here to make it back to 5 grams? 4.5 plus 0.2, 0.3, right? Okay, so the mass of water loss is now less. Okay, kenapa is less? Actually, in that it's not less, but it appears less because of this 0.2 grams of water vapor coming in contact with the residue. So now the residue appears heavier. Okay, so this is a bit confusing concept, right? So because this 0.2 gram comes from water vapor, because we do not we expose the residue, right? We don't cover it with the lid. Okay, so the water vapor now makes our residue heavier. Okay, because our residue is heavier, this will have an effect on the mass of our water loss. But our water loss will now be smaller. So if we look at the calculation, if our mass of water loss is small, what happens to our number of moles? If this number is decreasing, our number of moles of H2O increasing or decreasing? It will also decrease because they are proportional. Okay, they're proportional to each other. So if the number of moles of H2O decrease, what happens to the number of moles of metal sulfate? Decrease as well. Okay. So if the number of moles of MsO4 decrease, the number of moles of our Fe4 decrease as well, right? Okay. So it's like a chain reaction. The effect is continuous. Now, if our number of moles decreases, what happens to our MR? It increases. Okay, so that's why the effect is, suggest and explain the effect of the calculated value of the MR. That means, since our mass of water loss is decreasing, number of moles of H2O decreases as well, which means the number of moles of MsO4.7 H2O decreases. This means our MR will decrease. Okay? So the reason why they increase is because number of moles is the bottom number, the denominator. So if this number goes down, the MR goes down. So the most difficult part of this question is understanding the first part, the fact that the mass of water loss will be smaller. Okay. Because you would expect, if you don't put the lid on, you expose the solid, you think, oh, there will be more water will be lost. So you think the mass of water loss will be higher. But you also forget that exposing the residue means they will pick up water vapor from the environment, which will cause its mass to increase overestimated. Okay? And this has an effect to the number of moles, to the mass of water, which is underestimated. Okay? So for 1 mark, that requires a lot of thinking. Okay? Right. For question 3, I don't remember. Have you checked? Have I given you the expected oscillation? Okay. So you can check. For the first one, you should have seen your yellow solution turning blue or green, and then to lilac. Now, I don't like using the word lilac. Basically, lilac is purple. Okay, light purple. So you don't have to worry about this because it is a vanadium actually. The element is vanadium, and I think we use a different formula, not exactly the ammonium vanadium 5. It's the ammonium vanadium 3. Okay. Right. Whenever you use potassium manganate, okay, please do not write down the solution turns purple. Okay. So you imagine you have a clear colorless solution. You add potassium manganate. When you add potassium manganate to the clear solution, what happens? Of course, it will turn purple, right? But that is not a change because the purple color is the original color of the potassium manganate. So you cannot say the solution turns purple because of course it will turn purple because of potassium manganate. If the potassium manganate changes to colorless, then that is an observation that you should note. Okay? The potassium manganate decolorized or it turns colorless. So please please remember that manganate is purple color. When you see a purple color somewhere, that's natural. That's the original color of manganate. Okay? If you want to write down it stays purple, it's fine. If you write down it changes to purple, that's wrong. Because that's not a change. Of course, when you see a purple color, manganate turning to manganese Mn2+, it becomes colorless. This is the redox reaction. Okay, that means your manganese has been reduced to Mn2+. Okay, sometimes you will need a little bit theory of your redox equation, okay? Especially for your question. Right, adding sulfuric acid to amplify, that means there is an acid plus something to form a hydrogen gas. So if you know that it's a hydrogen gas, amplify must contain a metal. Why? Because you add acid plus metal to get a salt, which is something that you cannot see, and hydrogen gas. Hydrogen gas is something that you can observe. So you can say that, oh, maybe amplified is a metal. It makes sense. Okay? It makes sense for acid plus metal to form salt, which is not something that you can observe, and hydrogen gas. So these are some of the things that you also need to have knowledge of to do qualitative analysis. Okay, so please make sure to do a little bit of reading as well for your students. Okay, FP6, FP5. FP6 is an aqueous solution that has been made by reacting solid amplified with dilute sulfuric acid. So that means it's the salt. Okay? FP6 contains the salt from this reaction. You agree? Yeah? Okay, now you're just adding sodium hydroxide and ammonia. So this observation can easily be referred to your qualitative analysis notes to test for cations. Whenever you use sodium hydroxide and ammonia, that means you are testing for cations. So please follow this table. Now, if you see a different color from what is stated in this table, that means that color is not right. You choose the nearest color to the one that is stated in this table when you are using either sodium hydroxide or ammonia. Okay, so for example, you see like, I don't know, black precipitate. Okay, for example, you have sodium hydroxide and you get a black precipitate. In this table, there's no black precipitate. The closest to black precipitate would be gray green precipitate. Okay, so always choose your observation based on the colors that are in this table. If you're using sodium hydroxide or ammonia. If you're using other reagents, again, same thing. Follow the colors that are here. For example, with silver nitrate, you should only either use white, green, or yellow. Do not write anything else. If you see black, repeat the experiment. Okay, if you see green, repeat the experiment. That's not supposed to happen. So whenever you carry out, especially question 3. Okay, I can tell you tomorrow, if I'm not mistaken, there are only 2 questions. So I imagine the qualitative analysis will be long. Okay? And I can tell you there is no titration. Okay? There's no titration. There's two questions only. And I would imagine, I forgot the question already, that if I'm not mistaken, there's no titration. Right? But if other titration, more than two titration. Okay? I think, as far as I can remember, there's no titration. So please really study for your qualitative analysis. Okay, learn your qualitative analysis. This is not the time for you to revise titration. Titration, you already know how to do at one point. Okay, so the most important thing for you, I think your main struggle would be qualitative analysis. Okay, and then for guesses also sometimes you have to be like you have to think about the test for the guest. You do not want to test for every single thing. Just because you see effervescence and then you say, oh, I'm gonna test with ammonia, and I'm gonna test for ammonia, test for carbon dioxide, test for hydrogen, oxygen, chlorine. This will take a long time. Okay? My best advice to you is to look at what you are adding. Macam mana sulfuric acid. You are adding to FP5, and you know that FP5 is solid. If you form a gas when you add acid, you think about the reaction, or what reactions do I know of acid? Acid can react with metal, hydrogen gas. Acid can react with alkali, raw gas. Acid can also react with carbonates. So possible two gases that you can try when acid is being added, either you test for hydrogen or carbon dioxide. Okay, so it's not easy, but if you have a strong theory, you know about the reactions, then you can do well for qualitative analysis. Okay, right, so identify FB5. FB5 must have contained, so FB6 is actually the salt from FB5. FB5 must have contained zinc 2 plus. Okay, so that means zinc 2 plus here, and the metal would have been zinc. Okay, so I will just write this down. FB5 is metal, FB6 is actually the salt. So zinc is FB5, FB6 is zinc plus something, I don't know. Zinc sulfate as well, because we're adding sulfuric acid. So zinc sulfate. Okay. Give the equation for the reaction of FB5 with sulfuric acid to make FB6. Again, this is the kind of question that you are expected to be able to answer. If you did not get the correct metal, it's fine. If you say you got a different metal, like magnesium, for example, you just move on. Okay? This is an acid-base reaction, which is something that you have already learned from O levels. You must know how to write the equation and how to balance them. Okay? Zinc sulfate plus hydrogen gas. You could stay simple. Sulfuric acid will be aqueous, zinc will be solid, zinc sulfate will be aqueous, hydrogen will be gas. Okay. I don't know if you still remember early last year, I gave you notes untuk practical. You still remember that? Ada I gave you at the very start. Did I give it to you? It looks like. Otherwise, I'll just upload that one time later and then we can have a look at it before. Let me have a look at the back. I can just have a sample for you. Okay, and then part C, I think part C is also quite self-explanatory. You need a little bit of knowledge of organic chemistry for this question. This one, have you seen this before? Practical skills. The name is the note is practical skills. Do you want to see this? I didn't give it to you. So basically, it gives you all the how to calculate error. It's also here. Okay. The notes how to calculate error according to the error of each apparatus. And then qualitative analysis notes is also here. So if you don't have this, and if I never give it to you, then I will upload them to the OneDrive later. Okay. Now, if you haven't checked the OneDrive, I have also uploaded all your practicals from practical number 1. They are in 2 different folders. Okay. Satu yang L6 punya practical, and the other one is Alpha 6 punya practical. Please read through all of them. Okay. Just so that you can recall back on what you have done before and what are the procedures. Decimal places, don't forget. Okay. Kalau ada only if there is titration, then you have to worry about the 2 decimal places, your table. Make sure you label your table fully. You can use pencil to draw the table, but use pen, ink to write down on the table. Bring a long ruler. Just in case, okay? Bring a long ruler. Make sure, now how do you know decimal places? Usually you follow the question. If the question is using the mass to 2 decimal places, you just follow the question, 2 decimal places. Okay? Units, axis, don't forget to label your axis if there is graph. What else? Enthalpy change, but I don't think there will be enthalpy change. If there's enthalpy change, MC delta T. Okay? If there's heating of solid, it will be mass. Qualitative analysis stuff. Make sure you know how to work out the qualitative analysis reaction. Don't forget to what's the instruction? Are you still probably Samantha? Let's send it to you. Please conduct ART test the night before or on Thursday morning. Are you given ART test? Ada. Okay. So conduct ART test the night before or on Thursday morning before attending the practical exam. Ensure your conditions are good. Code must be green or yellow. Bring all your necessary materials. I'll just follow this. If you happen to be a primary contact or positive, okay, don't do that. But if anything happens, please update in the group, okay? Just update in the name list whether you are undergoing self-isolation or quarantine order, okay? All right, so that is all for today. All the best for tomorrow. Please check which shift you are in. Don't forget your calculators. That code, you can bring your own or you can use the lab code. Have a watch with you, and don't forget my tips for you. Since there are only 2 questions, allocate 30 minutes per question to collect results. Okay? If you can do it shorter than 30 minutes, even better. Okay, so at least least allocate yourself 45 minutes to 1 hour to do the question, do calculation, to analyze results, to do graph plotting, and whatever. Okay? Please do not bring only 15 minutes or 30 minutes. You will not be able to do the question if you only need that much time. Time management is important. Have a look around you if there is a shared reagent. Shared reagent means, it means you're sharing that with other people, okay? If there's anything missing from your table, please ask and please say something. Don't just say, oh, maybe we're not supposed to have it. Ask. Sometimes there are times where some apparatus is missing from your setup, okay? Everything should be in front of you except weight balance. Weight balance you have to move around. I don't know what else, but I think everything should be in front of you. Unlike how you have been doing your practical, where you have to take, you have to walk apart, everything should be in front of you. So if you think there's anything that you need which is not in front of you, just ask the invigilator. Kalau the invigilator says, sorry, I cannot give it to you, that means we can't. Tapi, you never know. Sometimes it's either your cup ataupun ada mistake salah. Okay, error made by the lab technician. Alright? And don't forget to inform your subject tutors as well that you will be missing their classes tomorrow, whichever class you will be missing. Don't go to the wrong lab. Please make sure that you are outside the current lab. It will be, all the labs will be on the floor of the class. We will not be using our lab. Okay? You know this already, right? Your lab number and your shift number. Yes? I resend to you guys? Okay, I will just resend it again later just in case. Okay, you can go. Danish and Apple, and just the others can go. I just want
Bye, Nina. Bye, Nina.
I think you are missing one thing. Did you this outline? Okay. You're not okay. So you are not going to set up the last because I thought you forgot to attach them. So I know you didn't finish up. Okay. Thank you.
Thank you, Miss.
Bye, Nina.
Thank you, Miss. Bye.
Can you hear? Welcome, Salam. Can you hear my voice actually?
Yeah.
Dapat. Okay. All right. Thank you. Bye. Take care. So you won't be here tomorrow, yeah?
Yeah.
Nina.
Yeah, I won't be there tomorrow.
Oh, you will be here tomorrow?
Yeah.
Indah, you won't be here.
Yeah.
Okay, but I'll take note lah. So just so your code is red at the moment?
No, still green.
It's still
I haven't
green. Tapi because your dad is positive. Wait, someone is positive in the house.
Yeah.
Okay. So that means you're a close contact.
Yeah. Berapa hari kan, Miss, the
Usually 5 days.
The self-isolation?
5 days. When was the first day of positive for that family member?
I'm not sure. I was asleep last night. I think it was last night.
Oh, last night. Okay, then it will be 5 days from yesterday lah. Yesterday would be day 1, I believe.
Okay.
But you just keep monitoring. Itulah, you monitor yourself, and then if you develop any symptoms, then start taking your ART test.
Okay.
And then I will update you on how you are going to sit for your SAG practical. Maybe when you come back.
Okay.
Okay. Do you have any other question?
No.
Huh?
No.
Okay. All right. Okay then. Bye, Nina. Assalamualaikum.
Bye. Waalaikumsalam.